Hello class, we are in section 9.2 and we're looking at how to test the mean when the standard deviation is unknown, and we're focusing on the left tail test. I will be looking at some vocabulary in the textbook and also computing the different values to do our test statistics. Turn to textbook page 421 and let's look at the null hypothesis H0 and the alternate hypothesis H1. It says a null hypothesis is a statement that's under investigation or being tested. You will see statements like no effect, no difference, or things haven't changed. Your alternate hypothesis, it is a statement that is strongly wanting to reject that null hypothesis. On page 422, you have the types of statistical tests. A statistical test is left tail if the alternate hypothesis states that the parameter is less than the value claimed in the null hypothesis. And that's the one we're going to talk about today. When we see H1 is less than the null hypothesis, we know it is a left tail. We also know that it is a right tail when the H1 is greater than H0, and it is a two tail when H1 does not equal H0. Very, very easy. P-value is on page 425. And the main thing I want you to notice about p-value is the smaller the p-value computed from sample data, the stronger the evidence is against the null hypothesis. That is very important that you lock that in. We also have on page 426 the level of significance, which is used by the symbol alpha, your Greek alphabet alpha. It is the probability of rejecting the null hypothesis when it is true. And when we're looking at these types of statistics, we want to make the assumption that the null hypothesis is true. We want to assume that it's true starting off. So the level of significance is the probability of rejecting H0 when it is true. And this is the probability of a type 1 error. And we do have type 1 and type 2 errors on table 9-2. Your procedure on page 428, the procedure on how to conclude a test using the p-value and level of significance, alpha. And these are some things we're going to see in our lesson today. So very important that we know about this procedure. It says if the p-value is less than or equal to the level of significance, we reject the null hypothesis and say the data is statistically significant at the level alpha. If the p-value is greater than my level of significance, we do not reject the null hypothesis. So the p-value is less than alpha, we reject the null hypothesis. If the p-value is greater than alpha, we do not reject the null hypothesis. All this will make sense once we start putting some numbers in place. Now turn to page 439 and we're going to look at the procedure on how to test the population mean when the population standard deviation is unknown. So we're going to test the population mean when the population standard deviation is unknown. And you have 5 steps, so we're going to go through all those steps. Step 1, while I read step 1, I want you to go ahead and read over the problem. Step 1 procedure says, in the context of the application, which you see here, you want to state the null and alternate hypotheses and state the level of significance. Read this question very carefully. I want you to lock in some key points. I want you to lock in that the average delivery time is less than 6 hours. I also want you to look at the different delivery times, which is rounded to the nearest hour. I have 10 different delivery times. And I also want you to notice that the level of significance is 5%. So let's write down some of this information. We said that the random sample for the amount of time taken to deliver packages to the address, it has 10 different delivery times. And you have an average delivery time of less than 6%, and our level of significance is 5%. So very important that you look at those 3 key points. And we're going to go back and look at that table and look at that conclusion. We want to state the null and alternate hypothesis. We have our H0, which is our null hypothesis. We have our alternate hypothesis, which is H1. And we have our level of significance, which is already given to us, which was 5%. And I'm going to convert that to a decimal, 0.05. The easiest way to identify the null and alternate hypotheses is to look at the alternate hypothesis. The given information is going to tell us what the alternate hypothesis is. It says the average delivery time is less than 6 hours. That right there will be our alternate hypothesis. And our null hypothesis will be the mean is equal to whatever that value that was given to me, which is 6. Your goal is that you're going to either reject or not reject the null hypothesis. If you are seeking evidence of something, you want to reject something in favor of it rather than not rejecting it. So whatever you are seeking evidence for, it goes in the H1 slot. So we're seeking evidence of the mean value being less than 6 hours. Now, we have completed step 1. Let's go to step 2. And I'm on page 439. Step 2 says we want to find the mean, the standard deviation, and n from this sample. If the population, with the population mean from H0 to compute the sample test statistic. The formula to do our test statistics is T equal X bar, which is our sample mean, minus our population mean, which we already have, divided by our sample standard deviation, divided by n. Some of the information we already have. My population mean is given to me. It's 6. I have 10 delivery times. But I don't know what my sample mean is or my sample standard deviation is. But I do know how to go on the Desmos graphing calculator and input that information to find my standard deviation and that mean for my sample. So let's go to Desmos and practice over that. And we have done this already in our previous note, but let's just review over it one more time. I'm going to hit the plus sign and click on table. And it gave me a X and Y table or a T chart. And I'm going to input that data, those 10 delivery times, I'm going to input into X1. So we have 7, 3, 4, 6, 10, 5, 6, 4, 3, and 8. So we have our 10 data values into our calculator. So I'm going to now go to functions, stacks, and I'm going to click on standard deviation, or I could have typed in standard deviation. I want the information for the table X1, so I'm going to say X1. Okay, again, notice that it says X1 and my numbers are under X1. So my standard deviation for my sample is 2.27. Now I want the mean of the sample, so I'm going to go to the mean, and I'm going to say X1 again because I want those same pieces of data, and my mean is 5.6. Now again, you can type in standard deviation and input the 10 values, and then type in mean and input those 10 values. But if you do a table, that helps you from doing so much extra work. So do the table, and then that way you can the command will understand that X1 represents those 10 values. Let's go back. Now we have our sample mean, which is 5.6. And we have our sample standard deviation, which is 2.27. We have everything we need. We can now input it into our problem now. We have 5.6 minus 6 divided by 2.27 divided by the square root of 10. And we're going to input this on the Desmos scientific calculator. And it is so important that you understand how to input this information into here. Because if you do not input it right, you will get the wrong answer. So we're going to take our time and we're going to input this into Desmos. You need to use parentheses to separate the numerator from that denominator. I'm going to say parentheses 5.6 minus 6. Close that parentheses, divide. I need to add a second set of parentheses, because if I do not do that, it's not going to give me the answer I need. The answer is going to be off. So parentheses, we're going to say 2.3, and then definitely test it on your own so you can see how the answers change when you didn't use parentheses. Divided by 10. And then you can go out and close parentheses. So we can see that our test statistic, T, equals negative, and it's negative 0.549. So let's go back. And we have T is approximately equal to negative 0.55. Also on step 2, it says we want to find the degree of freedom. Your degree of freedom is n minus 1. We know that n is 10 minus 1 equals 9. Look at step 3. Step 3 says use the student T distribution and the type of test, one tail or two tail, to find or estimate the p-value corresponding to the test statistic. So we already know that this is a left tail from page 422. So if it is a left tail, that makes it a one tail. So we've already identified that it's a one tail. We are using a T distribution and not a Z distribution because we do not know the population standard deviation. So because we do not know the population standard deviation, we are using a T distribution. Very important that you know that. I'm going to go to our p-value generator. So if you notice, I just Googled p-value generator, and I'm going to click on the very first one. We are looking at the p-value from a t-score. That's what we just found, a t-score. So we're going to click on the second one. And notice the information they gave us. They want to know what is our degree of freedom, what is our significant level, and they want to know if it's a one tail or a two tail hypothesis. We already have all this information. We've already found our t-score, which was negative, and I do have it already set up, negative 0.55. And we have our degree of freedom, which is 9. And of course, it is not perfect. So take your time and work on it. Our degree of freedom is 9. We have our t-score, our degree of freedom. Our significant level is 5%, which is 0.05, and we know that it was a left tail, so it's a one tail. Let's calculate that and see what happens. As you can see, your p-value is 0.297851. So we have a p-value of 0.297. I want to do step 4. It says conclude the test. If the p-value is less than or equal to alpha, then reject the null hypothesis. And if the p-value is greater than or equal to alpha, then we reject the null hypothesis. And we know alpha is our level of significance, which was the 0.05. I have a p-value of 0.297 less than or equal to 0.05. 0.297 is greater than 0.05. So I need to know which statement is true and which statement is false here. If I look at this, I'm thinking about 30 cents and 5 cents. So think about dollar values. If I look at this, I have 30 cents is less than 5 cents. Is that true or false? Is 30 cents less than 5 cents? That is false. 30 cents is not smaller than 5 cents. So our answer is the 0.297 is greater than 0.05. What does this mean? This means that we do not reject the null hypothesis at 5% level of significance as P is greater than 0.05. That's what that tells me. Step 5 says interpret your conclusion in the context of the application. So for step 4, we know that we do not reject the null hypothesis, which was the mean equals 6 at 5% level of significance as P is greater than 0.05. So in conclusion, it says while the sample mean was 5.6 hours, there is not enough evidence at a 5% level of significance to infer that the population average time for delivery is less than 6 hours. So that is it on how to test the mean value when the standard deviation is unknown.